this video, I'm going to discuss how Stellar Cyber's platform, which has NDR capability as a cornerstone, can help you to protect both your OT and IT environment. OT and IT are converging. Why do I say that? Because OT environment is changing due to the industrial automation, and Ethernet and TCP/IP unifies the whole network. Each device has an IP address. They are statically assigned. All the connections, they're all connected through the Ethernet via hierarchical communication. POCs don't talk to POCs, but they talk to HMIs, the human-machine interface, through SCADA protocols. And HMI talk to the ERP, the MES manufacturing execution systems, which are designed to help plan, track, and the execution to improve your operational efficiency. This introduced a challenge because now the attackers are attacking the OT environment through lateral movement from IT to OT. So Stellar Cyber's solution can help you to use one solution to cover the both IT and the OT environment. Stellar Cyber has these unique security sensors that can be deployed distributedly in your environment. It has different forms and sizes, can be a hardware box or virtual machine, and it has a DPI engine embedded in it that can inspect your network traffic. The DPI engine not only recognize thousands of IT protocols, but also recognize hundreds of SCADA protocols and IoT protocols. It also has a Stricada IDS engine embedded in it, so it can take the commercial IDS signatures, detect OT-specific exploitations as well as IT exploitations. Sensor also has another capability. It assembles files from the network traffic to detect malwares that's being downloaded to your environment. And on top of that, our sensors can also collect firewall logs in your OT environment. If you don't have the span traffic to allow the sensor to inspect traffic, it can collect your firewall logs and do detections on top of that. So the sensors can be deployed in your OT environment, in your DMZ. It can also be deployed in your IT environment. On top of that, the sensors, we also have the third-party integrations to collect the data from your email, cloud, endpoint, and data centers in your IT environment. All this data are sent to our central platform for threat intelligence, enrichment, normalization, and then we use machine learning to do detections and correlate the result into what we call cases. On top of that, the last capability we have is allow you to take action, not only in the OT environment, in the IT environment, but also in the OT environment, because from our sensor, you can take action, you can run a script, for example, to configure some ACLs on the switch in your OT environment to prevent, isolate some host. So it has from the data collection all the way detection correlation to the response. So this is the main console of our platform. I first and then go to the knowledge base here. In our knowledge base, you can see we have a large language model based chatbot. So I can ask questions, show me the OT deployment, for example. Then here says, okay, yes, the OT deployment document that details deployment scenarios, detection use cases, and the technical capabilities. And then it also provides you the link. So let's click on the link. Here you can see all our documentation about our OT deployment. We have not only the text, but we also have videos. So here this link will take you to all the OT videos that does the OT security introduction in our platform, the fundamentals, the security, and how do you secure your OT environment with cyber. And it also has OT demos. So here you can see it discusses about all the connectors, parsers, sensors, and detection we have in a single platform, do both OT and IT. The ability to integrate any IT and OT sources in a single SOC platform, and also the technical capabilities. As I mentioned earlier, we have a DPI engine that understands 3,700 total protocols, 57 SCADA protocols, and 18 IoT protocols. It has an IDS engine embedded, and malware AV, NTA, NDA protocols using supervised and unsupervised machine learning. It also has asset discovery capability to do the inventory of this automatically discover the asset in your environment from all the data sources. It has a DMZ log collection, L3 device log collection, and OT product log collection. And finally, we have the case correlation. So here, click this to expand, then you can see DPI SCADA references, all the protocols we support here, and the IDS signature references, and the detection use cases, for example, because all the collect all the metadata of your network and identify the applications, so we can detect all the protocols occurring within your SCADA network, like anything that's not supposed to happen, except the protocols allowed. You can create the alert when that happens, or there's a segmentation violation because we monitor east and west as well as north-south traffic. So you can look at the segmentation violation and also network attack detections like IDS signatures with commercial feeds, and malicious files, malware detection, anonymous communication patterns, and the IT to OT lateral movement. So here we detail about the detection or deployment scenarios. There we use the ISA 95 Purdue reference model to do level 4, level 5, level 3, level 2, level 1 model that. And then we have different deployment scenario details. So here, I'm not going to go to detail, but you can see there are a lot of resources here about how to deploy in your environment. Now, let me go back to the platform. I want to show, we mentioned about threat intelligence, have a threat intelligence platform that has feeds from built-in feeds, as well as customer can bring their own feeds. So you can see we have a lot of paid commercial feeds like ET Pro, and also the DHS OpenFish, those type of feeds. And you can also view IOCs here. Let's search for SCADA related. So you can see we have about 291 IDS signatures that are SCADA specific. So let me go to demo a real case incidents, or we call cases, as the actual cases that we created when monitoring the lab environment. And then we have two demos. One is from the simulate attacker traveling through an IT network into the OT network and compromising essential level 3 assets in OT environment. And then another case is a layer 2 to layer 1 attacker compromise OT equipment once in the OT environment. Which one? Why do we have two cases instead of one? Because of the size of the graph I'm going to show you later on. And then this is a Purdue model, how we set up, basic setup performing the attack result is basically, this is what I'm going to show you later on. It's on the level 4-5. The OT user tries to accessing a phishing URL and then downloaded a malware agent from that phishing site. And then this OT user, this machine runs a series of suspicious commands, which shows that the downloaded malware agent has been run as the attacker gains control of the OT user. And then a OT user runs Nmap to scan local machines and discover OT server. And then uses the credential dumped by Mimikatz to log on to the OT server to private exploit anomaly reporting this connection confirms this propagation. And then the same scanning happens on the OT server, and the attacker uses this WinRAM to propagate to OT workstation. And the attacker uses Nmap to discover the OT PLC that exploits the SCADA Siemens Factory Link 8. So let me go back to our platform. Here, let's drill down to this OT L3, L45 exploitation. So these are all the detections we found. In this case, you can see the phishing URL is visited as our private exploitation anomaly, PowerShell suspicious events, Mimikatz credential dump. So these are all the detections our system detected in a simulated lab environment. And we also show this in a graphical way. On the right-hand side, you can see OT user. This machine IP address is 10.33.4.133. And then if you look at it here, it's phishing URL. So it accesses the phishing URL, and then it downloaded malware from this site, downloaded the malware onto this machine, and then here you can see it start to do the port scan, Nmap port scan, and do a lot of malicious, suspicious event. We should see private to private exploitation detection. And we can also click to the details of that detection, say in internal traffic, rarely seen exploit attempt with the IDS signature user agents. WinRAM, right? We in the attack description, I talked about WinRAM. So this is evidence that it happened. And we can also show the timeline here of all the events. For example, the phishing URL is clicked, and then malware, we detect the malware, and then a lot of suspicious activities, uncommon processes, internal port scan, all this, and then this did the Mimikatz credential dump, and then escalated itself and lateral movement moved to OT server. Let's go to the other case, see what happens after the data move to the OT environment into the OT server. So this is the OT server machine, and then let's look at the timeline. See, it started to do the scan again. So it found this OT workstation, right? And then it moved to the private exploitation. This one is from this OT workstation to the OT PLC. Exploit this IDS signature SCADA Siemens Factory Link, this vulnerability, buffer overflow vulnerability, because it did the buffer overflow attack. And then here you can see exploited that vulnerability. Then we see the PLC checksum being changed. So we see this shows us all the details of how the attacker moved from the IT environment to OT, and then did the lateral movement, and then leveraged the SCADA vulnerability, OT vulnerability, and changed overflow, corrupted the image on the PLC, which caused the checksum change. And then how do we respond? See here on the response side, we can block IP because we know that the OT user, that was the first one that's being compromised. So we can say OT user is 10.33.4.133. So we can block it from your firewall, and direction is directions. We can do forever, or we can say let's block it for 5 hours and do the investigation. So here it says your firewall action is being triggered. Then we can see how the attack happens, connect the dots together, and allow you to stop it before it causes more damage.